Hello everyone and welcome back to the new video of this channel. So today we'll be solving a problem which is a linked list in binary tree, LeetCode 1367 problem. So let's see the problem statement. So problem say that we have given a binary tree root and the linked list head of as the first node. We have to return true if all the elements of the linked list starting from the head and corresponds to from downward path connected in the binary tree, otherwise return false. In this context, a downward path means a path that starts from some node and goes downwards. It means we have given a binary tree and also a linked list. You can see here this name is head, and we have to find out if the all elements of the linked list are in order, are in same order, and all the elements are present in the binary tree. As you can see in example 1 also, we have given this binary tree and also a linked list. In linked list, the elements are 4 to 8, and you can see if we traverse the binary tree or if we use the DFS technique to traverse this, because BFS, we can use BFS also, but DFS is more optimal to use. And if we use a DFS technique, you can see 4 is present and 2 is also present and 8 is also present, and there is a path to go 4 to 8. So our linked list is present in binary tree. So in this case, we will return true. Let's look on the example 2. You can see here this is a binary tree and this is the linked list. We have to find out 1426 is present or not, and is there any path to go from 1 to 6. So you can see here if we traverse the binary tree, then we will find 1, and if we go on the right, then 4, then left 2, then left again, then 6. So there is a path to go from 1 to 6. So in this case we will also return true, because our linked list, our fully linked list is present in this binary tree. So in this case we will return true. So let's understand how we'll solve this problem. So our approach will be DFS, because I told you about this कि DFS टेक्निक क्या होती है, डेप्थ में जाने के लिए होती है. BFS यूज कर सकते हैं ब्रेथ फर्स्ट सर्च, बट वो लेवल वाइज ज्यादा प्रिफर होती है. बट इन दिस केस if we want to go in depth, so in this case we will use DFS techniques. So let's see how we'll solve this problem. So we can use two pointers, like you can see this approach part. Firstly, what we'll do, we'll create a tree node star. Like if a data type is tree node, so we'll create a tree node which name is current, and we'll check if all the elements of the linked list are present in this binary tree or not. So 4 is present, then again 2 is present, and then again 8 is present. So 4 is here and here also. So there are two 4s. So which 4 we have to take? So that is the main point of this problem. So if we take this 4, okay, so then again I will go to 2. So 2 is present here. If 2 is also present here, then I will go to 8. 8 is present here, but 8 is not present here. So we know there are only one path, 4 to 8 this path, and this is only connected path, like single path. So that's why we'll take this path. So our task is to create a tree node and then check for the path exist or not. So let's do the coding part, and this coding part is very simple. Uh, let's explain about the how we'll tackle this. Like what I will do is basically I'll create a current pointer which is initially at the head of the linked list, and I will move the current pointer. Like I will check like current ka value if is equal to root ka value. Root is this binary to root ka value. Then in that case I will increase the current pointer, and then also I will check the head value. Also if head key value is equals to the root value, in that case what I will do, I'll increase the head pointer also. And the third case will be reset point. Reset pointer is basically current will be at the head. So let's do the code so that we can understand properly. So what I'll do, I'll create a DFS, and in DFS I'll pass head comma root. I'll tell you why I'm passing head two times. So it should be a boolean type. So let's create a bool DFS, and in DFS I'll pass link list node star head and list node star, so it should not लिस्ट नोड एक्चुअली, अगर ये लिस्ट नोड होती है, ठीक है, उससे कोई फर्क नहीं पड़ेगा। लिस्ट नोड स्टार्ट करंट एंड ट्री नोड स्टार्ट रूट। ओके, सो इट मीन्स मैं क्या कह रहा हूँ, करंट को भी हेड पे पॉइंट कर रहा हूँ अभी, हेड तो हेड है ही, और करंट को भी हेड पे पॉइंट कर रहा हूँ, ठीक है। नाउ आई हैव सम कंडीशन, इफ लाइक मेरा इफ करंट इक्वल टू नल, अगर मेरा करंट नल हो जाता है, इट मीन्स करंट पॉइंटर क्या है, करंट इज बेसिकली शोइंग द लिस्ट नोड वैल्यूज, sorry linked list values, because current is in starting is at the head pointer, and if we increase the current pointer again and again, like if current is at the 4, then again current will be at 2, and then again current will be at 8, then it will be null. So if current equals to null, it means it has traversed all the values of the linked list. So in that case I can simply say it's a true. And second case is if root equals to null, if my root is null, it means there is no binary tree, so I can't find out the linked list in that case. So in that case I can simply say it's a false condition. These are two conditions that I have to check. Now I have to check a condition, if root key value, or I can say initially current key value equals to root key value. If both values are same, if current value is equals to root value, root is showing this binary tree, so in that case I can simply increase my pointer, so which is current equals to current ka next. Else if case, if head की value equals to root की value, see current is the pointer that is pointing initially pointing out the head, and in that case I am increasing the current pointer if the values are same. But what if the head value equals to root value? You can see here 4 is present two times here and here. 2 is also present here two times. 2 is here and here. So that's why I am taking a current pointer that is pointing out the all the elements, and I am taking head pointer also. ठीक है? So in that case I can increase the head pointer. So head equals to head का next. And third condition, which is the reset pointer. Reset pointer condition. In this condition, what I will do, I will simply current equals to net. Current will point out the head pointer. So this is the, and at final, after this I can return left वाला part or right वाला part. So that's why DFS of head comma current comma root का left, and yeah, or DFS of head comma current comma root का right. So in both direction I am going and checking the conditions. So now let's run and see is this will work or not. Yeah, so there is a root का right, ये क्या होना चाहिए. हम्म, ये क्या कह रहा है कि नॉन वॉइड फंक्शन रिटर्न. ओके, सो इट शुड बी रिटर्न टाइप ना, बिकॉज इट्स अ बूलियन टाइप. Yeah, it is working perfect. Let's submit it and see. You can see it is getting accepted. So what basically I did is I'm creating a function, and function I'm checking, I'm initially taking two pointer, like head pointer is this one, and I'm creating a current pointer also, which is starting is at the index or is at the head pointer, and I'm checking if current equals to null. In this case it means I have traversed all the values of the linked list, so so there is a path, so that's why I'm returning it as a true. And if there is no binary tree, so in this case I am returning false, and I'm checking if current value is root value, then I am increasing the pointer of current, and if head value is root value, then I am increasing the pointer of head pointer, and third condition, which is the reset pointer condition. And in this case, the current pointer will be at the head pointer because we are changing the head pointer also. And at final, we are going left and right part. So this was the simple code. And if you find this helpful, then please like, share, and subscribe to the Kiliman.